Nancy, I'll let you go ahead and get rolling.
Okay, thanks. Hi, everybody. Welcome back. And glad to see everybody. Just want to give you a quick rundown of what we're going to do tonight. First, I'll be asking if you have any questions about the practice problems, and then we're going to do some work on helpful math skills, and we're going to use some examples in horticulture. That's the first half of class. The second half of class is where we're going to learn to calculate plant materials quantities, and that'll be, a number of different types of situations. Next week, we're going to do volume. And for those of you, just so you know in advance, I might be putting a little fertilizer applications in next week. Because I think I told you the first session, I was a little worried we were a little jam-packed in session 4. So just so you know, next week we might begin fertilizer applications after we complete volume. So just want to give you a heads up on that. All right, do we have any questions on the practice problems, or was it helpful to have the problems and then the solutions? Nothing big? Okay, I don't see anybody.
A quick question, where are the solutions?
They should be in the classroom. So if you hold on a second, we only show the solutions for the current week. So if you go into the online classroom, and I can actually, well, maybe I shouldn't because I have a teacher's screen, but right under, so for each week, so for session 1, if you open up that little tab on session 1, and then you look at the list, under that, the last 2 items are always the practice problems and then practice problem key. Have other people been, have you see it now? Okay, great. It is, you won't see it immediately. We give you a few days into the week before I'll open that. And but if I forget, please reach out, because I think I have to do that.
Got it. Thanks.
Sure.
I thought it was a great refresher.
Great. Oh, I'm glad to hear that. All right, I'm going to try to call up my PowerPoint here. Might take me a couple of tries. Hold on just a second. Oh, I have to ask Tim to allow me to screen share.
All right, you should be good to go.
Thank you.
Yep.
Okay, do you see my PowerPoint? Yes, great, okay. There we go. All right. Let's go ahead. Okay, so for helpful math skills, one of the, I think, most essential math skill, it's helpful, actually it's helpful for everyday life, is the isolation of X. So we're going to talk about that a little bit. And then we're going to talk about proportions, and we use isolation of X when we're solving an unknown in a proportion. So let's go through that. So all kinds of problems in horticulture involve solving for some unknown value. So just as a reminder, the unknown value in any equation is identified by the letter X. So here's an example. So also as a reminder, an equation is a mathematical statement of equality. So it always has an equal sign, and everything on the left side of the equal sign is equivalent to everything on the right side of the equal sign. So when we're solving for an unknown, when we're trying to figure out what X is in any given equation, we have to manipulate the equation so we can isolate X. So in doing so, we have to make sure, because it's a statement of equality, whatever changes we make on one side of that equal sign has to be the same as the changes we make on the other. And we'll demonstrate it in the next couple of equations. So here's an equation where we're going to solve for x in an equation with addition. So x plus 4 equals 12. So the first thing we need to do is isolate x. So it's alone by itself on one side of that equal sign. So the way to do that is if it's x plus 4, we need to subtract 4 in order to get x alone. So since we have to subtract 4 on the left side of the equation, we also have to do it on the right side of the equation. So x plus 4 minus 4 is x, and 12 minus 4 is 8. I try to use super easy numbers in each of these to demonstrate how it works. So here we are with subtraction. It's a very similar process. So the equation reads x minus 5 equals 10. So in order to isolate x, I have to add 5 to each side of the equation. So x minus 5 plus 5 results down here in x. And 10 plus 5, since we have to do the same thing on each side of the equation, is 15. Okay, so when we're solving for x in equations with division, you can handle it a couple of ways. I like to write it out this way. So the original equation is x divided by 4 equals 2. So I rewrite that as x divided by 4 in a fraction equals 2. So I know when I look at this, that x divided by 4 in a fraction form, if I multiply this side by 4, creating 4x over 4, I know that 4 over 4 is equivalent to 1, and that allows me to isolate x. So on this side of the equation, we're going to multiply by 4. So 4 times x over 4, as you see down here. And of course, since I'm multiplying by 4 on the left side of the equation, I have to do the same on the right side. So 2 times 4. So x equals 8 in this instance. And then for multiplication, the equation is kind of interesting. It's just 5x equals 20. So again, I use the fraction format because it's easy to see. So in order to isolate x, I have to divide by 5. And of course, I have to divide by 5 on both sides of the equation. So 5x divided by 5. Of course, 5 over 5 is 1. So that isolates x for us. And then 20 divided by 5 is 4. Okay, so I'm going to move on to ratios and proportions because you'll see some similar things here. Okay, so if you wanted to find a ratio in math, it's the relative size of two quantities. And we can express this in a couple of different ways. The way that we find it to be most useful in solving problems is to write it as a fraction, a over b. And it reads, now if we were doing math in a math class, it would be written this way, a colon b. So we would read it a is to b and a is to b. It's just a different way of writing the same thing. So here's something written as a fraction. We would read this as a ratio of 1 to 2, and also here a ratio of 1 to 2. But you can see this left way of writing it is in a fraction format. Okay, so that leads us to proportions. So a proportion is the relationship of equality between two ratios. We know it is because it's got an equal sign here in the center. So this ratio would be A is to B and C is to D. And A is to B equals C is to D. We can also read it this way using the colons, but I don't find that as useful. So here we go. Here's a proportion with some numbers in it. So this proportion reads 1 is to 2 as 4 is to 8. And because I use simple numbers, you can see that relationship very easily. When you use more complex numbers, you don't see it as easily. So in a proportion, the product of the means is equal to the product of the extremes. And you can see on this slide, I wrote them with the colons rather than writing them as fractions. So the means refers to the two inner numbers that I've got highlighted in blue font. And the extremes refers to the outer two numbers of a proportion. So the product of the means is equal to the product of the extremes. And you need to interpret the word product is that we multiply those numbers. So let's show this. So here I've got that same proportion with the means highlighted in blue and the extremes highlighted in green. So the product of the means would be written as 2 times 4, and the product of the extremes would be written as 1 times 8. So, and we've proven this as 8 equals 8. So I know that those two numbers are equivalent. So here's where it helps in some of our problem solving. Rather than writing those proportions with the colon between the two numbers, we're going to write them as fractions. And this concept of the product of the means is equivalent to the product of the extremes is cross multiplication. So you can see if we cross multiply, taking the denominator over here on the left times the numerator on the right, that's 2 times 4. That's equivalent to 1 times 8. So cross multiplication. So 2 times 4 is 8, 1 times 8 is 8. So if you were to write them this way, A is to B as C is to D, then A times D is equivalent or equal to B times C. So I just wrote it in math speak there. Okay, so now we're back to the isolation of X. So we've got this proportion, 1 is to 2 as X is to 8. Because X is the unknown in this situation. So we're going to go ahead and do some cross multiplication here. And we're going to multiply 2 times the X equals 1 times 8. So I went ahead and rewrote it down here as 2X equals 8. So the next step for solving for X is to isolate it, or get it by itself on one side of that equal sign. So we divide both sides by 2, and that will allow X to be isolated because 2 over 2 is 1. And then 8 divided by 2 is 4. So in this proportion, we've solved for X. X equals 4. Again, 1 is to 2 as 4 is to 8. Okay, so let's solve a problem. So this is a situation where we want to figure out how much fertilizer to use. And we've been given the appropriate rate of fertilizer. So in this situation, we've got a 5-10-5 fertilizer, which is just a description of the type of fertilizer, is to be applied at the rate of 2 pounds for every 100 square feet of garden space. And we've gotten that rate information usually on the bag, if it's a consumer product, or there's some kind of recommendation that we've read in a horticultural reference to give us that rate of 2 pounds for every 100 square feet of garden space. But a horticulturist needs to make this application to a perennial flower border that measures 250 square feet, not 100 square feet. So how many pounds of 5-10-5 are required for this application? So the easiest way to do it, particularly if the numbers are a little complex, these are easy numbers, but if the numbers are a little complex, it's super helpful to set it up this way. We know we want to apply 2 pounds of fertilizer to every 100 square feet. So how many pounds of fertilizer do we need for 250 square feet? So we set it up in a proportion format and then solve for X. One of the most important aspects of this math is that we have to make sure we put pounds of fertilizer on the top, or well, it doesn't have to be on the top, but they have to be on the same. They have to either be numerators or denominators. And then the square feet have to be together, either in the numerator or the denominator. Also, these units must match. We have to have square feet and square feet. We can't mix numbers there or units there, and we can't mix up this. So when we're solving for X, we're solving for pounds, just as pounds are in the rate. So here we are again. 2 pounds of fertilizer is prescribed for every 100 square feet. So how many pounds of fertilizer do I need for 250 square feet? So I cross multiply 100 times X equals 2 times 250. We want to isolate X, so we're dividing both sides by 100. So 100X divided by 100 is X. And then 2 times 250 is 500, and then divide by 100. So when we solve for X, we find that 5 pounds of fertilizer are required for 250 square feet of garden space. So you can apply this proportion technique and solving for X in a lot of different situations. Okay. So one of the tasks that we're sometimes faced with is to calculate how much material we need. And you can just use the techniques we've just described for that if you know how much material you need for a given area. But every time we calculate how many of something we need, it's truly just an estimate. And sometimes we have to further modify the estimate based on the experience of the designer or the installer. So why would we need to modify the estimate, say for plants or for gravel or whatever? First of all, this is something I have a lot of experience with because I used to manage a campus garden. We have to plan for transplant losses. And we'd like to have the plants be of the same type and the same age. So we always order a little extra. Sometimes we have planting irregularities, such as planting along a curve. If it's not plant materials, sometimes if it's a bulk material in particularly, it's hard to estimate how much material you need, often because they're sold by weight and you're measuring volume, but materials like soil, sand, gravel, and concrete. And then sometimes when we're doing paving work or wall work, the more complex the problem, the more materials we really should have as a little bit of extra. So all of this is calculating, you can say overages or a little bit extra just in case. So here's a table. This is from a textbook. And these are some recommended overages. So this is percent additional material that might be required for each of these different types of products. So the first line is pavers and wall materials used in simple designs. So we need to plan on 3 to 5% extra. And then pavers and wall materials used in complex designs, you need to up that to 6 to 8. Now, these are just general guidelines. If you have, if you're using, those manufactured materials, the concrete pavers and wall materials, that company may have a recommended overage, and you need to pay attention to that, whomever the manufacturer is. And then for bulk materials such as gravel, sand, and soil, we need to add about 10 to 15%. And the reason that's so high is that it's just a harder amount to estimate. Concrete usually need to have 2 to 3% extra, and sod and ground covers 5% is common. Now, that being said, if you've got someone who's routinely installing bedding displays, say in commercial sites or campus sites or theme parks, or public gardens, they'll have their own extra material. They'll have their percent overage that they historically need. So once we've estimated the quantity of a product needed, then we need to figure out how much extra. So that's where that overage calculation comes into play. So here's an example. A ground cover installation requires an estimated 500 plants for the project. And the manager just determines she needs a plan for 5% additional plants to account for curves in the bed and transplant losses. So this is just a hypothetical situation, but you could use the reference tables I provided or your experience to find what that percentage is. But for this situation, we're using 5%. So if you want to figure out what 5% of 500 is we simply rewrite 5% in the percentage as a decimal. So that's equivalent to 5 over 100, if that helps you remember. So as a decimal, it's 0.05. So of means multiply by. So 5% of 500 is 25 additional plants. And then you have to, of course, add it back to the 500 and then order 525 total plants. So I like it to take a shortcut to the answer. And instead of doing this two-step problem, I do it in one mathematical problem. So if we need 500 plants and we want to add 5% extra, we'll put the 0.05, but we need another whole 500 plants. So I multiply 500 times 1.05. So what that's going to give you is one whole 500 and then another 5%. So if you run that through your calculator, you'll find it's 5.25 total plants. You can use that for sales tax too, or tips. Well, no, can't use it for tips, but you can use it for doing a quick calculation of sales tax. So anyway, that's two ways of calculating the same thing. And that is it for the helpful math skills. Any questions on those concepts? Anything I need to go back and revisit? All good? Okay. All right, so we're going to get a new share going. Hopefully you're seeing a new PowerPoint.
Yes.
Thank you. Okay. All right, so now we're going to talk about plant materials quantities. We just talked about overages and talked about needing so many plants for a certain area. So we're going to talk about how we figure out how much plant material we need. So the first situation involves lawn seeding. And I do it first because it's a little more complex. So we'll take a look at a typical grass seed label. So if you're not familiar with turf grass, and I'll warn you, I'm married to a PhD in turf grass science, so we hear a lot of turf in this house. So anyway, when we buy grass seed, we're not usually buying a single variety of grass in the bag. Usually it's a combination of species. If it's a single species, it's probably a combination of different varieties of the same species that makes this grass seed adaptable for all the little microclimates that are in a typical lawn area. So here on the left, you can see the grass varieties listed here. So there's 2 perennial ryegrass and 1 Kentucky bluegrass. And you can also see there's some inert ingredients. So if you total all these percentages, they'll come up to 100. But what's the important thing is knowing it's 32% of the citation, 32% of Seville, and 34% of Kentucky bluegrass. So the other information that's required to be on a seed label is a test for germination. So not everyone, if out of 100 seeds for the citation, only 92 3/4 seeds are going to germinate, and so on. So you can see there's different germination percentages for each of these different varieties of grass. So, but when we're calculating how much grass seed to apply, we're calculating it based on the seed that will germinate. So that's defined as pure live seed. So it's defined as the pure seed in the lot that can be expected to germinate under laboratory test conditions. So obviously the conditions during germination out in the field is different, but we use laboratory testing so everyone can compare the quality of the seed that they're buying. So to calculate pure live seed, we multiply the percentage of pure seed expressed as a decimal that's on the label by the percentage of germination, also expressed as a decimal. So it's percent pure seed times percent germination gives you percent pure live seed. So let's take a look. So for this particular seed blend, it takes a couple of steps because there's 3 different varieties of grass in this bag of seed. So here's the math for each. So we took the 32% citation perennial rye and we wrote it in the decimal format, 0.32. And we're multiplying that by the percent germination, which is 92 3/4%. And we write it as a decimal as 0.9275. So you multiply those 2 together and it gives you 0.2968 or 29.68 pure live seed. So we repeat that calculation for each of the different varieties of grass found in the blend. Okay, so we've done that in the last step 1. We've calculated the pure live seed of each. And now we need to calculate the pure live seed for this particular lot of seed, for this bag of seed. So all you do is add them up. So you add the 0.2968 from the citation, the 0.2928 from the Seville, and the 0.3349 from the Blacksburg Kentucky Blue. So we have a total of 0.9245 pure live seed, or 92.45% pure live seed. So it's a little more complicated calculation. Okay. So here's an example of seeding an area. So we've got this Kentucky bluegrass and perennial ryegrass blend, and it's to be used at a rate of 3.5 pounds pure live seed for every 1,000 square feet. And this is a rate for establishing a new lawn. Overseeding is a different rate. So this new lawn measures 18,000 square feet. So how many pounds of the seed described in the label will be needed for this job? So here's a restatement of the question. So what we need to know first is if 3.5 pounds are needed for every 1,000 square feet, how many pounds will be needed for 18,000 square feet? That's a pretty easy thinking with those numbers, but if you have weird numbers, we're going to go through using a proportion. So the rate was 3.5 pounds of pure live seed for every 1,000 square feet of turf area that need to be established equals how many pounds of pure live seed for our 18,000 square foot project. So we cross multiply 1,000 times X or 1,000X and 3.5 times 18,000. So 3.5 times 18,000 is 63,000. We divide both sides by 1,000 so we can isolate X. And if we solve for X, it's 63 pounds of pure live seed. The other way to calculate it is the rate is 3.5 pounds pure live seed for every 1,000, and then we need to multiply it by 18,000. It gives you 63 pounds. Sometimes people kind of mess this up, so I always go back to a proportion. It just makes me feel more comfortable. I've got my pounds on the top and my square feet on the bottom, so I know I'm doing the correct math. Either way, of course, works. Okay, so we're not done yet. So we've discovered that we need 63 pounds of pure live seed, but we need to know how many pounds of that seed blend we're going to use. So we've learned from calculating the pure live seed percentage for this particular blend that it's a 92.45% pure live seed. So that means for every 100 pounds of seed, you have 92.45 pounds of pure live seed. So this is just a different way of expressing that percentage. So that's 92.45 pounds pure live seed for every 100 pounds of seed blend. And then I need 63 pounds of pure live seed. So how many pounds of the seed blend do I need to use? So again, you can cross multiply 92.45 times X, put it right down there, 100 times 63. We divide both sides by 92.45. And turns out, oops, sorry about that, we need 68.14 pounds of seed blend to give us 63 pounds of pure live seed. So obviously we have to put a little more on because we're compensating for the fact that not every seed germinates. Only 92.45 seeds germinates in every 100 seeds. There's an alternate method for calculating this if it makes more sense to you. We say not 0.9245 times X many pounds of seed blend will produce the 63 pounds. So we need to isolate X, so we divide each side by the 0.9245. And so we divide the 63 by 0.9245, and we get the same 68.14. It all depends on how you look at it. Again, I like to go back to the full proportion. But if you read it through and say this, you can understand how that math works. Depends on how oftentimes you use these skills. Any questions on that?
Hi, yeah. So when they have on the bag that it covers a certain square footage, I would have assumed that they took that into account
Yes.
already.
For consumer product labeling, yes, they would have. So if you're going into the garden center and you're buying a bag of seed that covers 500 square feet or whatever, that will have already put those specifications into the recommendation. This is starting with, this is not using a consumer bag. This would be using a bag that you would buy at a seed supplier. Usually, this would be a place where landscapers would buy the product. But that's what goes into giving you that recommendation. It's real good to, actually, the practice of looking at that label is actually a smart thing to do. One of the things I look for is how much weed seed's in there, and I don't like to see very much. So you can check for that. And then I'm kind of a fussy person because I'm married to a turf guy. But I like to look at the different varieties of seed and then see if I can find something out about them. So you like for them to be local recommendations.
Can I ask a question?
Sure.
Since you know quite a bit about grass and you live obviously close to Longwood Gardens,
Mhm.
What do you recommend? Like you pick up all these packages
Mhm.
and it's kind of overwhelming. Which one is going to do the job?
Well, first, I would, if you're in PA, I would look to Penn State for extension bulletins on the topic. The first thing I look for is what's my lawn like? You know, is my lawn in full sun? Or is my lawn a combination of environments? Or do I have a really shady property? And there are different turf species recommended for each of those types of environments. The seed blend that we used in our demonstration is primarily for sunny areas. But if it's a sun and shade blend, it'll mix in some other types of fescues. The other thing that we're finding, we have a primarily sunny yard, and we began our yard 25 years ago with a very nice bluegrass perennial ryegrass blend. And we're finding that with the heat and the drought we've been experiencing over several summers here, that we're converting most of our lawn to a bluegrass turf type tall fescue blend. We find that just is a little more resistant to die out in really hot and dry weather. So there's some really great turf type tall fescue blends that if you have a sunny area, it's a real durable grass species to get. A lot of the sod that we can get locally has a combination of Kentucky bluegrass and turf type tall fescues, mostly because the Kentucky bluegrass has rhizomes and stolons that hold the sod together. Tall fescue is a bunch grass, so it doesn't have things that hold a sod piece together. It's about the best general advice I can give you.
Oh, great. Thank you.
Anybody else have any other questions? Oh, okay. You can see we're zipping right along. Okay. Plant materials. Well, okay. We're going to go on to meadow seeding. I just know there's a lot of interest in seeding meadows. And so I thought I'd do a little research on meadow seeding. I noticed that there's some kind of something coming up at Longwood on establishing meadows. There's a class, some kind of I think just a class, a one-day class on that. So if you're interested in meadows, you might check out the offerings with continuing ed. So anyway, I started by finding a good seed supplier. And if you look at the bottom of this slide, you can see I reference Ernst Seeds because I found that A, it's a Pennsylvania company. B, they had lots of really great information on establishing a meadow. The one thing I couldn't get is a label, but you'll understand when I go through the example. So I set up the hypothetical situation of a mini meadow measuring 10 feet wide by 150 feet long. So I kind of have a suburban lot, but if you had like an area where you could have, you know, more of a meadow strip, this would be what you would do. Okay. So anyway, this is something designed to attract and sustain pollinator species. So I looked at Ernst's site and they had a really nice butterfly and hummingbird mix. And the rate they recommended was 8.5 pounds of this mix per acre. So understand this is a mix of flowering plants, a mix of annuals and perennials. And this is their recommended rate. So I have to assume that all the adjustments are made for pure live seed. Now, I noticed that particularly for commercial customers, well, actually any customer, it seems like they want you to call them and talk to them. Because I would guess that A, they want to make sure you've got the right product for your situation, and B, I'm guessing that each mix each year is going to have a different rate recommendation. Let's just say, you know, the germ test came out on the low side, they might recommend 9 pounds per acre. You see what I'm saying? So I'm assuming they'll make some adjustments. So interesting enough, when you establish a little meadow, you need to use some seed, obviously a hummingbird, butterfly and hummingbird mix, but you also, they want you to add a cover crop of grain oats. And this is actually in addition to seeding, in addition to seeding that hummingbird mix. So that this grain oats is recommended at 30 pounds per acre. Just so you know, if you read through all their materials, there's different cover crop recommendations depending upon the time of year that you're establishing your meadows. So getting back to the math. So how many pounds of butterfly and hummingbird garden seed mix will be needed, and how many pounds of grain oats? So this is actually a fairly straightforward calculation, but we'll go through it. So this is first calculating the butterfly and hummingbird garden seeding mix. So the area measures 1,500 square feet, and the rate is 8.5 pounds per acre. So we want to make sure the area units are the same. And an acre is equivalent to 43,560 square feet. So when I set up my proportion, I say I need 8.5 pounds to every 43,560 square feet, which is equal to an acre. So I want to know how many pounds of seed I need for my little 1,500 square foot mini meadow. That's kind of hard to say. So anyway, we cross multiply. So 43,560 times X, and then 8.5 times 1,500. So 43,560X, 8.5 times 1,500. To isolate X, we need to divide both sides by 43,560. So you can see here's the other side of the equation. It's 12,750 divided by 43,560. So we need just a small amount of seed, 0.29 pounds of seed. So roughly 1/3 of a pound of seed for this seeding. Okay, so we also need those grain oats to apply as well. And the recommendation for grain oats was 30 pounds per acre. So we rewrite that as 30 pounds for 43,560 square feet, which is equivalent to an acre. and I want to know how many pounds per my 1,500 square foot area. So 43,560x equals 30 times 1,500. 30 times 1,500 is 45,000. Divide both sides by 43,560 to isolate x. You get 1.03 pounds of seed. So one question that might come up, 30 pounds versus 8.5 pounds per acre. The seeds are different sizes and different weights. So it'll become evident, but even I know the recommendations for grass seeds, like bluegrass is teeny tiny and tall fescue is giant. It's also heavy. So that's why the gray notes are big seeds and they're heavier. Then all the species that go into that hummingbird and pollinator mix is small and lightweight. So that's why there's such a discrepancy in the recommendations for pounds per acre. Any questions about that? So I just wanted to do, the math's not super complicated, but I just thought it'd be fun to figure out meadow seeding versus lawn seeding. Okay, so now we're going to move on to annual flowers, herbaceous perennial ground covers, and then geophytes. So geophytes are any kind of underground thing. We mostly think of them as bulbs. So
of the grain versus the other.
can you say that again? You're breaking up a little bit.
What would be the sequencing of the grain cover crop versus the other seed mix?
My interpretation for reading their site was that they go on at the same time.
Oh,
But I would definitely go in and read the fine print since
Okay.
I'm not experienced.
thanks.
Yeah, the other thing is attend that Longwood training. I think it's on site, meeting with the folks that work the meadow.
Okay.
Okay, so in order to do this, in order to calculate how many flowers, perennials, bulbs, and other underground structures, the first thing we need to know is how large a garden area is to be planted. So that's the first piece of information that we need. And we spent a bunch of time last week talking about calculating area. And then the other thing we need is what is the recommended on-center spacing for the plant being planted, or another way to describe the same thing is how many plants should be planted within each square foot of garden space. So we need to know those recommendations. So along with this part of the class, there's a handout that you can find on in the classroom, and I can pull it up later. But it's a handout where I've got some recommendations for spacings of some common annual flowers, herbaceous perennial ground covers, and then mostly spring flowering bulbs for your geophytes. So you can look at those. The spacings are often described as ranges. And I guess I need to explain to you that let's just use annual flowers for an example. I always plant a little mailbox garden in front of my house. So I always will fill it with annuals. And Longwood has, so call that a little mini bedding plant display garden. Longwood has bedding displays, and then places like the major theme parks, particularly Disney, has some very elaborate annual plantings. And one of the things you have to decide when you're going into this is how quickly do I want my bedding display to fill in? So I'm not made of a ton of money, so I tend to space things pretty far apart. I'm only doing it once, then I might refresh things in the fall and do something fall. I'm also cognizant of disease issues and plant competition issues since my plants are going to be in the ground a long time. And I'm patient. I'm patient to allow the plants grow together. But if you're, say, Disney World, maybe you're not. You know, Disney World's pretty famous for overnight changing their bedding displays. And they plant a lot of plants very close together so that it fills and it looks beautiful very quickly. So just realize that's why there's the range of plant spacing. So you just have to find what's right for you in your situation. So, okay, so plant spacing is described as the distance between plants. So we usually read that as OC or on-center dimensions. So as shown in this picture, plants that are planted 6 inches on center mean that they're planted 6 inches apart. So you can see in this little diagram, I've got, you know, this little measuring stick here that I've labeled as 6 inches. It also means that each plant occupies a space that measures 6 inches by 6 inches. So that's why you see the little square boxes here. So we have an on-center dimension of 6 inches, but we talk about redefining this on-center spacing to the number of plants per square foot. So it's super easy to use the number of plants per square foot in a calculation because all you need to do is multiply by the square foot of the area that you want to plant. So how do you do that? How do you make that conversion? So here's an easy example. So this is a situation we've just described. We've been asked to plant these plants 6 inches on center. So here's a diagram of that. They're planted 6 inches apart. Each plant occupies 6 inches by 6 inches. So each plant occupying 6 times 6 inches or 36 square inches for every plant. So every plant takes up 36 square inches. So on the math side, I write a proportion like this. 36 inches is occupied by 1 plant. 1 square foot, or 144 square inches, because we have to keep the units the same, or 12 by 12, is occupied by X plants. So I'm going to solve for X. So 36X equals 1 times 144, or 144. Isolate X, so we're going to divide the left side by 36 and the right side by 36. So you come down to 4 plants per square foot. And then I just put this little reminder that a square foot is 144 square inches. So here in my little diagram, I show you that. So, you know, each of these boxes is 6 inches, and you can see this would be 12 inches, as you see right here, by 12 inches. So there are 4 plants that fit in that space. So that's how I do the math. And then here's a table, which I think this is the first page in that handout, where we've converted the on-center spacing to the number of plants needed per square foot of garden area. So it's the spacing multiplier. And it's all down to plants per square foot. You can see if it's really tight spacing at 2 inches between each plant, you can fit 36 plants in a square foot. If you have really wide spacing, like 24 inches between plants, you only have 1/4 of a plant for every square foot. So don't let those weird numbers less than 1 mess you up. And of course, if we plant on 12-inch on center, it's going to be 1 plant for every square foot. Okay, so here's an example. This is an annual color planting or bedding display, or however you like to describe it. So we've got a planting bed that measures 2,250 square feet. It's to be planted with petunias on 8-inch centers. So 8-inch centers, if you use the table, is 2.25 plants per square feet. So how many petunia plants will be required for the bed? So we take that area of bed space, the 2,250 times the equivalent plants per square foot for 8-inch centers, which is 2.25. You come up with 5,062.5 plants. So you can't plant a half a plant. So I always round up. So taking a little farther to a planting situation, if a landscaper needs 5% overage to account for curvy bed lines and transplant losses, how would you modify that quantity? So we take the 5,063 plants we just calculated and we add the overage. So we add the overage of 5%, that's represented by the 0.05 here, and then we add another whole 5,063, that's represented by the 1 there. We come up with 5,316.15 plants. Again, I just round up to the next whole number. So to make it even more interesting, these plants are sold in flats that contain 72 plants. So how many flats do I need to buy? So I take that 5,317 plants divided by 72 plants for every flat. That comes up to 73.8 flats or 74 flats. I be careful on these. Well, this is a 72 flat, which is a fairly small plant, but it's also a large quantity of plants for every flat. Be careful not to forget how important, that extra, that 0.8 portion. Like if you were to go down, you'd be really shorting yourself plants. So like 0.8 times 72, be shorting yourself 57 plants. So you don't want to do that. You want to go up and add an extra small quantity. Should be about 14 plants. So be careful about that. Any questions on calculating annual flowers? Using those square foot? I got another example. So here's a herbaceous perennial ground cover example. So we've got this hypothetical 3,000 square foot stand of Tiarella cordifolia or foam flower we want established. And we're going to be patient. This is a perennial. And if you're patient, you can plant them on 2-foot centers. So that means if they're 2 foot on center, it means it's 4 square foot for every plant. So how many plants per square foot would that be? So I'm just showing you the math. You could go back to the table, but for 2 foot on center, it's 4 square feet for every 1 plant. And I want to know how many plants in every single square foot. So again, 4 is to 1 as 1 is to x. So cross multiply 4x is right down here equals 1. So we got to divide both sides by 4. So x equals 1 over 4, and 1 over 4 is equivalent to 0.25. So it's only 0.25 plants for every square foot. Okay, so back to the problem. We've got 3,000 square feet to fill. We're planting them on 2-foot centers, or 2 feet on center, or 2 feet OC. And that's equivalent to 0.25 plants per square foot. So 3,000 square feet times 0.25 plants per square foot. That means you need to purchase 750 plants. Okay, then moving on to an example for flower bulbs. So this is an imaginary situation with Narcissus thalia. And the planting bed measures 1,075. They're planted 6 inches on center, which if we go back to the chart, we know that that's equivalent to 4 bulbs for every square foot. So if we've got 1,075 square feet and we multiply by 4 bulbs per square foot, that's going to be 43,000 bulbs. Bulbs are pretty tough in terms of like a big display. There's really not any room to plant extras, and you don't know if you're successful to the following spring. So it's really helpful if you have a very reliable bulb supplier, because there's kind of no going back on that one. You still can calculate overages if you know that there might be some errors in planting. And then you would hope that every bulb is viable that you buy. But if, let's just say, your supplier said it says it's a bit of a bad year for bulbs, you may want to, do a small overage for that. But in this case, if they're good quality bulbs and you feel confident, then you're just talking overages for planting issues. Any questions on those?
This is just for illustration, right? Because you would never plant that many bulbs in 1 foot, don't you think? Or 6 inches. If you put tulip bulbs like that, it'd be all overgrown by the next couple of years.
6 inches on center for daffodil bulbs in a home gardening situation. I would probably go more on the 8-inch side. We can look at that table in a minute, but 6 inches on center for a tulip display is probably pretty accurate. So here's one of Longwood's displays. Now understand that narcissus are reliably perennial and will, develop new bulbs, and they don't really spread a ton, but they'll create more bulbs, offset bulbs. Tulips are not reliably perennial. There's a few that are, but generally speaking, they're not. So these would be pretty tight spacings, as you see in that display there. Let's see. I'm going to pull up that table. I can find it. Let me stop the share and start over. Here we go. Let's see where it is. Let's see if it's on this page. Yeah, I bet it's on this page. Hold on. Okay, do you see my handout? That pop up? Yep, okay, great. Thank you. All right, so here is that on center spacing. That's just that first table on the PowerPoint. Let me go down here to bulb spacing. And as you can see, narcissus, the large species, are 6 to 8. Again, there's a range. Me, I'd be going on the 8 side. You can see there's a couple different types of those. And then the standard tulips, they're still recommending 6. I don't know if I have the patience to plant one every 6 inches in my own garden, so I'd probably still be a little wider spacing, but for display purposes, that's what they're going to aim for. And then the wild or the species tulips are tiny bulbs, so they'd be planted much tighter. So these are I just pulled these off of various bulb references. You can, your supplier also, I mean, I usually buy my bulbs from Brent and Becky's, which is out of Virginia, and I use their recommendations when I'm planting. Has anyone heard of those folks, Brent and Becky's? If you Google them, they'll come up because they're an online seller. The quality is always really good. They also breed plants. So then let's scroll down on this handout. Here's that annual flower spacing. Can you see how the ranges are in on center spacing? So I've added as many as I could think of for this list. And then the last list are ground covers. These are perennials. So I tend to even be even more generous with perennials because I'm not a real big fan of having to dig up and divide things too frequently. And I'm okay with a little blank space for a little while. But you can do whatever you like. The plants always sort of adapt. So I've got a pretty decent list of those. And I pulled from a number of references on those. Does anybody have a favorite place to buy perennials?
I'm pretty close to the edge of the woods.
Okay. So you buy from there. I usually buy, locally. Here in Kennett Square, I go down to Lancaster County and go to Groff's Plant Farm. But I found a new place. It's called the Perennial Farm in Glen Arm, Maryland. It's a wholesale operation that April through October, and I don't know whether it stops October 1 or October 31, you'd have to check. They're open on Saturdays. I think it's like, I don't know, roughly 8 to 4 on Saturdays to the general public. So anyway, I was doing we had some construction, so I was replacing I was adding some beds and replacing some plants. So I left with a carload of perennials. So I thought the prices were pretty reasonable for retail.
I'm sorry, what's the name of the perennial?
It's called the Perennial Farm.
Oh, great, thank you.
Yeah, and it's in Glen Arm, 2 words, Maryland. From here in Kennett Square, I think it took us between an hour and 15 minutes to get there on a Saturday morning. And it was a really nice drive, actually. We just headed down Route 1 and super nice people. You pull up and if you have a list, they have a map and they'll tell you where it is in their operation to go find the plants. They said, please drive your car. It's really big. Just don't go between greenhouses, follow the road. So we had our list and we had our map and we stopped at outdoor production fields and we stopped at various different types of hoop houses and gutter connected houses and pulled all the plants I needed for my plants. It was great. And then we drove back and they checked us out of the back of our car. So it was a good experience.
Oh, that's great.
And the quality was really nice too. So that was a new thing for me. All right. I will turn that off. Am I done already? It's 8:10. I'm finishing early today. Are there any questions or concerns or anything I can do better?
Here's one question. When you actually do the plans and you have big plants besides little plants, how do you make that adjustment? If one takes 12 feet or 2 feet and then Like, how do you do the off-center for mixed border?
Well, a mixed perennial border, say for example, or a shrub border, you really have to work with some design skills, and you need to, use those spacing recommendations and draw something to scale. So that's kind of the stuff of a landscape design class. But, and I was fortunate enough when I was going through my undergraduate days to take a couple of landscape design courses. So I learned how to use the tools, but you can do the same thing with graph paper. So I would use graph paper. Depending on the type of graph paper, you can designate each square to be 6 inches by 6 inches or a foot, and simply draw your bed. And then if you do have spaces that are areas of the same plant, then you can use the tools that we've taught you. But otherwise it's really better to just use landscape design skills and do it that way. If you are someone that enjoys working with computers, there are plenty of software packages for homeowners for design out there. Designs. I'm a little more of a scientist than a designer, though I do like to design. Do you have a question?
Nancy, I have a question, and you don't have to answer it tonight, but I just wanted to register that one of the math things that I have struggled with is converting scales of plans. So, if I'm presented with a plan that's 1 inch equals 30 feet, and I want to convert it to an 1/8 inch equals 1 foot, I get all tangled up.
Okay.
Figuring out how to enlarge and how many, anyways.
Okay, I'll have to think about that since it's more of a design skill. So tell me in the context that you're doing that.
So I receive from a client a survey plan.
Okay.
And the scale is 1 inch equals 30 feet. But I want to do a plan in 1/8 inch or 1/4 inch. So I want to enlarge the survey plan that I have, so that the scale changes, but figuring out what the ratio is so I know how much to enlarge by.
Okay, so you don't use an architect's or a engineer's scale to pull the distances off the map. So
yeah, I do, but I guess I'm starting with a plan that's in a scale that is not the one I want to use. So I want to transfer to a different scale.
Can I make a suggestion?
Yeah.
I'm a designer and I do have to use scales a lot. If you're using your survey, try to find something in the drawing that is a universal size, say a 3-foot doorway or a 3-foot walkway, and then do you have both scales? Do you have an engineer scale and an architecture scale? And then utilize what you can find that is recognizable, a measurement that is recognizable, that you know for sure or you're pretty sure about, and then try to convert that. Does that make sense? Without being able to see both things, the drawing, I can't explain it better than that, but find something in the drawing that you can identify as a certain measurement, and then you can use that to determine what your other measurements are on the drawing. Unfortunately, it's going to be very complicated. It's going to take you a few hours, but then you'll have it. You'll figure it out that way. Does that make sense?
Mhm.
Yeah.
That makes sense to me, yeah, because you're it's the drawing, if it's done 1 inch equals 30 feet, can be enormous compared to the portion of the project that you're doing. Because
It's-
yeah, you're working
It's-
off, residence or something like that, and yeah, I can see that.
Can I make a suggestion too? If
Go
you
for
I actually had something similar, and I just took it to a decent print shop. I mean, not like a Staples or something like that, but just an actual like place that does architectural drawings and things like that. And I'm like, I have it in this scale, I need it in this scale. And they can just do it.
Wow, I did not know that.
Yeah, I've done that too, but I'd like to be able to figure it out myself.
Your time is
So-
worth something.
Yeah, yeah.
I think it's a relatively simple math problem. It's just a ratio conversion, but I've gotten tripped up on it.
Yeah, I'll work through it. It's not something I ever do, but give me till next time to figure it out. I also have a designer friend or two out there that works at Longwood, so I could ask them as well. Hey, I've got this problem that someone asked me for math class. Do you have any simple? And he'll tell me.
Great, thank you.
Yeah, if I can't figure it out, he'll tell me. And even if he did tell me, I'd check him. I'm just that way. I'm a little type A. But yes, this is great discussion. I appreciate everybody participating. I know it's different. Do we have any? I don't want to keep people. I feel like you could use this time to look at the practice problems at least, and that would I always like to look at things right away after I've heard about them. So, does anyone else have anything they want to share? No, we're all good. Okay, well, I'm gonna close the meeting unless anyone has any questions.